So in this video, we're going to solve quadratic equations written as trinomials by using our factoring ABC strategy, but this time we're going to deal with trinomials where the a value is not equal to 1. So the ABC strategy for factoring is used when we are factoring what are called trinomials. So trinomials have three terms. You'll see 1, 2, 3, and you have a as the coefficient of x squared, b as the coefficient of x, and c as your constant at the end without a variable value. Now in this particular video, we're going to focus on things where the a value is not equal to 1. So in the previous video, we learned a quick shortcut that we can use when a is equal to 1. This video focuses on what happens when a is not 1, as it does take a little more work to write these into factored form and then solve. So notice here that we have a trinomial. You see the three terms, and we know this is a quadratic because of the x squared that we see here. So we're going to start off the same way that we started off before. Step 1 when we use the ABC strategy is going to be to find a, b, and c. So here we can see a is 2, b is -5, and c is -12. Then our second step is also still the same. We multiply a times c, so we take a times c, which in this case is 2 times -12, so that's -24, and we add to b, which is -5. So we need two numbers that multiply to a times c, which is -24, and add to 5. So if I start thinking through the factors of 24, I eventually find that -8 times 3 gives me a multiplication of -24 and addition of -5. So what we're going to do is we're going to rewrite this statement up here, and we're going to change this middle term right here to be -8x plus 3x. So it's just a rewriting process. So step 3 here, we're going to write 2x squared, and then we're rewriting this term to be minus 8x plus 3x minus 12 is equal to 0. So this ABC strategy is really called factoring by grouping, and what we're going to do once we've rewritten it using our two terms is we're now going to group these into pairs, and we're going to factor out the greatest common factor for each. So step 4, we find the greatest common factor for each. Well, 2 and 8 are both divisible by 2, and they each contain at least one x value, so this becomes 2x, and then in the parentheses we have x minus 4. So notice if I were to redistribute that 2x, I'd go right back. Then from here, I want to get the parenthesis parts to match. So we have, if we factor out a 3, we'll end up with x minus 4 in our parentheses as well. So since we have two matching parenthesis parts, what we can do now is we can group the coefficients of 2x and 3 together. So we have 2x plus 3 times x minus 4 is equal to 0. So remember, both 2x and positive 3 are being multiplied by x minus 4, so we group them together. So this takes a little bit longer to get us into factored form. Then from here, that ending process is exactly the same. We're going to use the zero product property to find our values for x. Notice we have something times something is equal to 0. So we set each little mini equation equal to 0. So I have 2x plus 3 is equal to 0. So I subtract 3 on each side and divide by 2 here. So I find one option is x is equal to -3/2. And then if I set my other part, x minus 4 equal to 0, I add 4 to each side, and I find that my other x value is x is equal to 4. So all we're doing is writing this trinomial into factored form by using this ABC strategy. So we start by finding a, b, and c. We then multiply a times c and add to b, and we find the two numbers that multiply, in this case, to -24, add to -5. Then from here, we rewrite this middle term using the two values that we found, and then we factor by grouping. We look at these in pairs, and we factor out the greatest common factor for each, so we get matching parenthesis parts, and then we group those two coefficients together. So let's try a second example here. So we're going to start with step 1, which is to identify a, b, and c. So we have a is equal to -1, b is equal to -12, and c is equal to -27. Then step 2, we multiply a times c, which in this case becomes 27, and we add to b, which is -12. So I need two numbers that multiply to 27 but add to -12. And if I think through the factors of 27, I find that the two numbers that multiply to 27 but add to -12 are -9 times -3. So I'm going to rewrite this term here as -9 plus -3. So here, step 3, we write -1x squared minus 9x minus 3x minus 27 is equal to 0. Then step 4 is where we group these in pairs, and we find the greatest common factor. So here I'm going to factor out, I notice they're both negatives, I'm going to factor out a -1, and then I'm going to factor out an x. So I have -1x, and then inside the parentheses becomes x plus 9. And then I want to get this parenthesis piece to match, so I'm going to factor out a -3. And that also becomes x plus 9. Then from here, we group those coefficients together because we have matching parenthesis pieces. So we take -1 and -3 and we group them together. So we have -1x minus 3, and then we have x plus 9, and that equals 0. So from here, we have now set this up into factored form. So I have something times something is equal to 0. So we can utilize the zero product property here because we have two things that are being multiplied and set equal to 0. So we set each part equal to 0, and we solve. So we subtract 9 here, subtract 9 here, and we end up with x is equal to -9 as one option. Then here, we add 3, so I have -1x is equal to 3. Divide by -1, and my other option is x is equal to -3. So for this third example here, what I notice is that it's not set equal to 0, and we know that if we're going to use the factoring strategy, that we're going to use the zero product property, so this needs to be set equal to 0. So I'm going to start by subtracting 12d from each side. So I have 4d squared minus 12d goes in the middle, minus 7 is equal to 0. Then from here, I identify a, b, and c. So I notice that a is equal to 4, b is equal to -12, and c is equal to -7. I then multiply a times c. So 4 times -7 is -28, and b is equal to -12. So I'm looking for two numbers that when multiplied give me -28, but they add to -12. So if I think through the various factors of -28, I eventually determine that -14 times 2 gives me -28, but adds to -12. So I now rewrite this statement right here with that middle term represented by -14 plus 2. So this becomes 4d squared minus 14d plus 2d minus 7 is equal to 0. Then from here we pair these up and we find the greatest common factor, which this first one we find is 2 and d. So we get 2d, and then inside the parentheses becomes 2d minus 7. Now remember, we want the parenthesis parts to match. So this second one here, the only greatest common factor they have is a +1. So we're going to factor out 1 so that the inside parenthesis is 2d minus 7 is equal to 0. Then, because these two parenthesis pieces are identical, we can group our coefficients together out in front. So we have 2d plus 1 times 2d minus 7 is equal to 0. Now from here, I have something times something is equal to 0. So this is the zero product property. And as a result, I can set each part equal to 0 and solve. So this first one here, I subtract 1, and then divide by 2. So I find that one option for D is that D equals a negative 1/2. Then my second option here is 2D minus 7 is equal to 0. I add 7 to each side, divide by 2. So my second option for D is that D is going to be equal to 7/2. So in this example, I again notice that I don't have the equal to 0 part. So I'm going to start by subtracting 2x from each side, and I'll combine it with the 1x. And then subtracting 4 from each side, and I'll combine it with the 2. So this becomes 6x squared minus 1x minus 2 is equal to 0. And then from here I start by identifying A is 6, B is negative 1, and C is negative 2. We then take A times C, and we find negative 12. B is negative 1, so I need two numbers that multiply to negative 12, but add to negative 1. If I think about the factors of 12 that would multiply to negative 12 but add to negative 1, I come up with negative 4 and 3. So I'm going to rewrite this trinomial here as 6x squared minus 4x plus 3x minus 2, and that's equal to 0. We then group these into pairs and factor out the greatest common factor. For this first one, that is just 2x, so I have 2x. And then inside the parentheses is 3x minus 2, plus the greatest common factor here, if I want the parentheses to match, is just 1. So I end up with 3x minus 2, again, is equal to 0. Notice the parenthesis parts match, so I can group the coefficients together. So we have 2x plus 1 times 3x minus 2 is equal to 0. Then from here we notice we have something times something equals 0, so that's the zero product property. So I take each part, so 2x plus 1 equals 0 and 3x minus 2 equals 0. So here I subtract 1, divide by 2. So I end up with an x value that is equal to negative 1/2. Then here I add 2, divide by 3. And my other x value is x is equal to 2/3.